So 2's out front. Is there any mathematical issues with me moving 2 to the back? No, there shouldn't be. I hate having 2 out front. Go ahead and put it in the back. Remember, we're not dealing with frequency right now. What does the negative out front of this function do? Great job. It reflects it over the x-axis. Great job. That's a great question. Can I subtract them and get a -1? Since the sine is attached by multiplication to the 3, they are not technically like terms. But if they were like terms, we would for sure want to do that. That's a good idea. So the amplitude, right? That's the number out front. Is it 3 or -3? The amplitude itself is just 3 because remember that tells you how high above, if this is just a quick little sine curve, the amplitude is how high above and how high below the peak and the valley is. Okay. So the amplitude would just be 3. Now, the period length, a lot of people want to jump just to a half. Okay. But remember, the equation of a period is 2 pi over b. 2 pi over b is the equation of the period. The b value itself is a half. So that's what replaces the b. Okay. Again, we don't know how long this period is yet. All we know is that the b value is a half. So what do I have to do to simplify this guy? You keep that red numerator, you change that division to multiplication, and you flip that 2 over 1. Great job. Giving you 4 pi as your period. Now we are still going to do beginning, end, middle, middle, middle. But I'm going to teach you a way because there were some complaints that it was a little bit confusing, which I agree. It's not easy. But I'm going to teach you kind of like the more straightforward way. It's actually on the board right behind me. Basically, you still want to end with beginning, end, middle, middle, middle. If you want to put that off to the side, beginning, end, middle, middle, middle. Remember, because this period follows that perfect pattern, right? So if I just start at x equals 0, if I start at x equals 0, where does the period end if its full length is 4 pi long? It ends at 4 pi. So the end will be 4 pi. My first middle occurs where? What's perfectly in the middle of 0 and 4? 2 pi. Oh, and yeah. Okay, yeah. The first middle, yeah. When I say first middle, I mean how I say beginning and middle. I'm talking about like the direct center of the period. Did you have a question, Jasmine? Yes. We have not shifted this graph left and right yet, so it's still fine for us to start at 0, and it's still fine after that. Um, I just like to start at 0. Yeah, good question. So the first. Thank you. The middle after. Great job. 1 pi or just pi. That's fine. And then the next middle would be 3 pi. You can just put pi. Yes. Now to get your y value, okay, your equation is this whole guy up there. So you can see it on the board behind me, right? You can see it over there that you're just plugging in. Again, these will be your y values. You're plugging in -3 sine of a half times 0 plus 2. That will get you your output. If you just want to plug it in and graph it, x comma y, that works, right? I like beginning and middle, middle, middle because I think it makes more sense in my brain. But if you want to do the full algebra step, there you go. It's right there. What's the only difference between that green step and then the one if you used 1 pi instead? What's the only thing that changes? The 0 will become a 1 pi. So again, if you want to do it this way, you can plug it in. Just plug it and chug it, which again is a lot of work in my opinion. So you kind of do you. Again, the only thing that's going to change each time is what you're plugging in. We are not going to take the time to solve it right now because I still want to show you beginning, end, middle, middle, middle. Um, like this is just another way to do it. But you would just use order of operations. Maybe I'll solve the last one as an example. So that's a lot. Again, I told you this way is a lot more work. The beginning, end, middle, middle, middle is supposed to be less work. That's the goal. So if I was going to solve this thing, this would be equal to -3 sine of what happens all on the inside? What's the only thing that's left when you multiply all that together? 2 pi, great job. 2 pi, and then a plus 2. So the sine of 2 pi, if you have a calculator that's real clutch, you can just plug it in. But if you didn't have a calculator, the sine of 2 pi, is that the x or the y value? The y value. So what's the sine of 2 pi? That's the x value. So it will be, this becomes -3 times 1 plus 2, which just will spit out a -1. Yep. Now, for me, in first or third period, you can thank them. They told me to put it on the graph. So just like beginning down there, the end would be at 4 pi out here. And then the middle is at 2 pi. And then the next middles are pi and 3 pi. So where does sine start? The parent function starts at 0, the origin. So we're putting an x there. Why are we putting an x there? What do we still have to do to it after we graph the period and the amplitude? We got to shift it up to and reflect it. So our steps for solving this are beginning, end, middle, middle, middle. Okay, that's what we just did. Now the x's come into place where you just deal with you put x's on the amplitude and the period. You do not shift it and reflect. You got to wait, in my opinion. This is one way to do it. There's probably 1,000 ways to do it if you keep looking on the internet. So sine, the period ends at 4 pi on the x-axis, and perfectly in the middle, it hits the x-axis again. What's up? So at pi, should it be up or down, and how much? It should be up 2. Great job. So I'm going to put an x up, or sorry, it should be up where? My bad, 3, because that's the amplitude. You guys can chain me real quick. 1, 2, 3. So the 3 is up there. So then my x at 3 pi should be down 3, 1, 2, 3. Now, those are my 5 points. Those are my 5 period, my full period. Don't connect them. But again, notice how it makes that full hill and full valley. You guys are telling me to still reflect and then shift it. Great job. So after you do the amplitude in the period, that last step is you want to reflect it and shift it. Again, if you don't like the purple, if it's too much, just do the old algebra. Just plug and chug, plug it in, get your x value, get your y value. So from here, if it's stuck on the x-axis, it stays there. It doesn't reflect at all. So you just have to shift those up 2. Again, it's at 0, so you just shift them up 2. I'm going to put a little dot up 2. Okay. Now, for the x's that are off the x-axis, I have to reflect them over the x-axis, 1, 2, 3. And then I have to reflect the other purple one above the x-axis, 1, 2, 3. And I have to shift those up 2 now. You got to reflect before you shift. It took me like 2 years of teaching this to really believe that, because I used to always mess this up. And now you can connect the dots. So for the people that were having a hard time of why are we doing x's, is because last week we didn't deal with reflections and shifts. What about the what? The dots are me reflecting and shifting. The dots are the actual peak and the actual valley. I know it's a lot.